Hello, everyone. Today we're going to be applying systems of linear equations. So we're going to get into some super fun and interesting word problems. So before we get into actually writing our own system and solving it, what I would love for you guys to do is try the Ignite at the top of the page. Now we have three methods that we've learned to this point. For this one specifically, I want you guys to try doing it using the elimination method. Either variable is fine, but pause your video now and give it a shot. All right, answer is up. Final answer, you should have got -3/6 as your final point. Now, in terms of eliminating, you could have done this a couple different ways. Again, whichever variable though you choose, it's really just a matter of getting them to have the same number and the opposite signs. So that's all I really did. Now I chose specifically to eliminate my x's. So I looked at those and I knew that excuse me. I know that 2 times 2 ends up giving me 4. So I didn't have to multiply the top equation really by anything because the bottom one multiplies to be that number, which is pretty nice. Now, could you have multiplied them by each other? Of course you could have, and it'll totally still work. But I just multiplied my bottom equation by 2. That would get me to the same number, but in order to get opposite signs, that's why I also multiplied by a negative 2. So after rewriting both of your equations here, then it's really just a matter of adding down and then solving from there. So dividing both by 17, that's how you get your final answer for y to be 6. Now, once you figure out what y is, then it's really just a matter of plugging it back into one of the original equations. So if you look at the problems that I did on here, I plugged it back into the second equation. So 2x minus 5 times whatever y is equals -36. And once you plug that back in and solve, that's where you get your final answer of x equals -3. Now, today, when we go about solving the different application problems, the first step for any of the problems that we're going to solve is obviously we have to first write our own system. Now, just as a reminder, anytime we're working with applications where it's a word problem, there's always going to be enough information for 2 equations because it's a system, right? If I say write the system, that means you should have not just one, but 2 equations that you can go through and you can solve. So let's start off with kind of like the first type of word problem that I could throw at you. And that's where, let's say, if we read this, it says, at the school pool party, Mr. Lewis bought 1 adult ticket and 2 child's tickets for $10. Mrs. Vroom bought 2 adult tickets and 3 child tickets for $17. Write the system that represents this and solve. Now, if we look through the problem that we're solving, pretty typically, most equations that we write are going to kind of follow a similar setup. And anytime we're working with any specific type of word problem, if ever you're working with money, there's usually almost always going to be at least one money equation where usually the things that you're adding, you're going to add up everything that you're buying, and then that equals a total amount of money, which again, that total always represents the amount of money that is spent on any one thing or on any trip to the grocery store or total of an order of something. And whatever it is that you're totaling up, your everything else, it's really just a matter of multiplying the price of each item. Usually there's going to be 2 items or 2 things that you're buying specifically. And it's always the price of that item times the number of things that you're buying. So if the price of apples is $3 and you're buying 4 apples, then you would take 3 times 4, and that would be 12 total dollars spent. And so anytime you're totaling things up, usually you want to know kind of those 5 things. You want to know the total amount spent, the amount of the second item that it costs, the number of the second item, the amount of items that you have, and then the price of the first item and the number of items that you're buying. Now, typically, you're not going to be given all that information. Usually, there's always going to be kind of 2 things that are missing. And in this particular one, it looks to me like since we have two specific people, we have Mr. Lewis and we have Mrs. Vroom, then you're going to write an equation for each person. And that's pretty typical anytime you have kind of two different companies or two different people that you're comparing prices to. Usually, each equation, you're going to write an equation that represents what each person bought or what each company spent money on. So that's what we're going to do here. Let's start with Mr. Lewis. So it says Mr. Lewis bought one adult ticket and two child tickets for $10. So we know for a fact he spent $10. That's my total amount of money. That's going to go on one side. And let's look at the rest. For the first item, it looks like he's buying adult tickets. Now we know the number of those that he's buying. We know he's buying one adult ticket, but we don't actually know how much it costs. That right there is your first variable. Now, you could use X and Y if you want to use A for adult tickets and C for child's tickets. Whatever floats your boat. Honestly, both are fine. But when I say define your variables, it just means tell me in words what it is. So if we don't know the price of the adult ticket, then that's what one of our variables is going to represent. It's going to represent the price of an adult ticket. And vice versa, same thing with child's tickets. It tells me that I know he bought two of them, but we don't actually know the amount of each of those child's tickets. So there you go. That's what C is going to stand for. And now you can fill things in. So for my first one, we know he bought one adult ticket, but we don't know how many he bought. So we're just going to use our variable in place of it. And for child's tickets, we know he bought two of them, but we don't know the price. So that's what C represents. And there's your first equation. And second equation kind of follows suit. Mrs. Vroom says she bought two adults tickets and she bought three child's tickets for a total of $17. So this right here now is going to be your equation that we're going to go through and solve. Now, in terms of method, whatever you would like to use, you can really choose any method that you would like. I'll kind of mix things up. I'll do one substitution and one elimination for today. So for this one, I'm actually going to use substitution. And the reason being is because if we look at our first equation, A is actually almost alone. So that's a really great equation that we can now go ahead and we can substitute. Now, in order to do any substituting, we have to start by getting this variable alone. So I'm going to move the 2C over to the other side. And now you actually know what A is equal to. So once I know what A is equal to, now it's really just a matter of taking A and plugging it in for itself in the other equation. Sorry, guys. Keep hitting the wrong button. So I'm going to take 2 times whatever A is, plus 3C equals 17. But I actually now know what A is. A is 10 minus 2C. And now once you get to this step, really I can ignore everything else. And it's just a simple matter of solving. 2 times 10 is going to be 20. 2 times negative 2 is going to be 4C. We're going to bring everything else down. Then we're going to go ahead and we're going to combine our like terms. Subtract 20 to the other side. Oops. And last but not least, we're now going to divide. Divide this by negative 1. And you know C is going to be equal to 3. So for the question that says how many child tickets were sold, for this particular type of problem, anytime it's a word problem, we're not going to write our answer as an ordered pair. We're just going to simply write it as a sentence. It's going to be $3 per child's ticket. And now we just have to really go about figuring out how much per adult ticket. And to do that, all we're really going to do is we're going to go ahead and plug it back in. I know C is equal to 3, so let's plug it in and see what the price of an adult ticket is. So let's see, 2 times 3 is going to end up being 6, and 10 minus 6 is going to end up being 4. And you just find your price for an adult ticket. It's $3 per child's ticket, and it's $4 per adult's ticket. And honestly, now that we know the price of these tickets, then we can really solve for any combination that you would want to buy. So for part D, it really says how much would 5 child's tickets and 10 adult tickets cost? Now that you know those prices, let's just plug them in. It's $3 per child's ticket. It's $4 per adult's ticket. And we can go ahead and now solve. 5 times 3 is going to end up being 15. 10 times 4 is going to be 40. And if I add those together, final answer, we know we're going to spend about $55 for that. So what I want you guys to do now, oops, sorry guys, is I would love it if you would go to the next page, and I would love it if you guys would try example 2 on your own. So pause your video and give this one a shot. All right, so hopefully, now, cool thing is for part A, when it says define your variables, you didn't have to use X and Y. If you had chose any 2 other variables like N for notebook or P for pen, honestly, doesn't matter. But what matters is your equation looks approximately the same. So your system, it should have been, sorry guys, let me move that out of the way. Your system should have looked kind of something like this. Because you have 2 people, you have John and Ariana, you should have written one equation for each of those people. So the first equation on mine, this represents John. It says he wrote, it's $4, or he has, oops, sorry. It's 4 notebooks, but you don't know how much he spent on them. So that kind of helps you figure out what your variables are going to be. Now, kind of another trick of the trade is when you're trying to figure out your variables, there's actually a sentence that usually kind of gives you an idea of what it should be. If you look at the last sentence of this, it says, what is the cost of 1 notebook and 1 pen? That's honestly how I figure out what my variables are. If it asks you what those things are, that means it didn't give them to you at the beginning of the problem. So that's kind of a neat way of figuring out what your variables are going to be. And it helps make writing your equations a little bit nicer. Because you know he bought 4 notebooks, you don't know how much they were. You know that he bought 5 pens, you don't know how much those were. And you know he spent a total of $7.65 on those specific things. And the same thing is actually now true for Ariana. It says she bought 3 notebooks and 3 pens. So it's 3 times the amount per notebook, 3 times the amount per pen, and she spent a total of $7.50. So anytime you're writing an equation for, or when there's 2 people involved or 2 companies involved, typically that's where we're going to start by writing our equations. And the rest is really just pretty nice. To solve, you can choose either elimination or substitution for this. I love elimination, and especially it's nice for this when you don't have a 1 in front of any of your variables. That's usually a hint that substitution is a little bit nicer, but I like elimination whenever there's a number in front of every variable. So, and then just it's a matter of choosing your variable. I chose to get rid of X. So I multiplied my top equation by 3, bottom equation by 4. And then to get opposite signs, I just chose one of those to make negative. So I chose to make the 3 negative. And once you do, then obviously once you distribute to everything in each equation, add down, solve, that's where you get your answer for Y, which represents the amount per pen. And then to find the amount per notebook, it's really just a matter of plugging in that number back into one of your equations, and you can solve for the price of 1 notebook. All right, so for your next one, I'm actually going to skip the last example from here. I want you guys to look down now at your homework for the day. So if you go to the 5D practice, if you guys could turn to the back of that page, I'm going to go through and do number 4, or let's see, I'm going to do number 3 with you guys, because there is kind of one last type of setup when it comes to solving different types of word problems. So obviously one of the first ones is kind of like the one we just did where there's two people with two separate totals, and you're going to write an equation that represents each person. But sometimes there aren't two people involved. Like if you look at number 3, it says Veronica has been saving dimes and corners. She has 94 coins in all, and the total value is $19.30. And it says how many dimes and how many quarters does she have? Now, from that last sentence, that right there tells you what your two variables are. You don't actually know in any of the information that they gave us. They didn't give us, I'm going to use Q for quarters and D for dimes. But be careful because if you just say Q quarters, D dimes, that's not exactly very descriptive. I actually would say when I'm looking for you to describe your variables, I want you to tell me what specifically do you not know. Now, you might say, well, Miss Hardy, it doesn't tell us what the price of those are. But realistically, don't we know how much a quarter is worth and a dime is worth? We know that a quarter is worth 25 cents, and we know that a dime is worth 10 cents. So be careful not to put Q equals 25, D equals 10 cents. We know how much those cost. That's kind of implied. What we don't know is the number of quarters or the number of dimes. That's what we're trying to figure out. Now you're probably saying, well, Miss Hardy, there aren't two people. So how do we write our two equations? Because yes, we still are going to write two separate equations. The thing we have to look at now is our two totals. Because even though we don't have two people, it does tell us that she has 94 coins in all, and the total value is $19.30. So if you don't have two people, it's still just a matter of writing two equations, one that represents each of those specific totals. Now, let's think about the 94. Now, 94, that just represents the number of coins. If you want to find the number of coins, that has nothing to do with the price. If I knew that I had 5 quarters and 5 dimes, I don't need to know the price of those or even how much I have. I know that I have 10 total coins. So when you're counting 94, when I'm counting up the total number of coins, I don't have to do price times the number of them. All I really have to do is just add up how many quarters I have and how many dimes I have. And that's what our Q and D stand for. Q represents the number of quarters, D represents the number of dimes, and you have your first equation. Now the second equation, here's where price comes into play. Because here I know I have to total, the total amount should be $19.30. So here's where I actually need the prices of each of those. Because we know a quarter is worth 25 cents, so 0.25. But if we're ever calculating a total price, remember it's always the price of the item times the number of the items. So since I don't know how many quarters I have, we're just going to use Q to take its place. And same thing with nickels. Nickels that cost 10 cents per nickel. And now you have your two equations. And solving, really, you guys can choose any method that you would like. Whatever you guys would like. I think for me, I almost think that maybe substitution might be a little bit easier on this one. Just because on my first equation, solving for either Q or N, not plus, sorry, equals. Running out of room, I wrote a little too big, but Q plus N equals 94 is going to go on one side. 0.25 Q plus 0, forgot the 0, 0.1 N equals $19.30. So I'm going to solve this by substitution. I want you guys, though, to try solving it on your own. So pause your video and try solving this by substitution. All right, final answer is up. You should have gotten your final answer to be 66 quarters and 28 dimes. Now, just so you guys are aware, I'm sorry, guys, I accidentally wrote N instead of D. So it doesn't really matter all that much. I'm just going to change. I use N instead of D throughout this entire problem. So N is just representing the number of dimes. Doesn't really matter the variable itself. But either way, if you're going to solve by substitution, your first step was to solve for either Q or N. In this case, it didn't matter which one you chose. I chose to solve for Q, so I subtracted N to both sides. And then it was just a matter of taking Q and plugging it in for itself in the other equation and solving. So for then, all I did was I distributed the 0.25, combined my like terms, and then I subtracted my 23.5 to the other side. And then last but not least, divided by negative 0.15 to get the number of dimes, which was 28. Which means to plug it back in, if I know there's a 94 total ones, really it was just a matter of subtracting 28 from that, and that helps you find out the number of quarters. So those are really kind of the two main types of word problems. Either you have something like number 3, where you have two totals, and you're going to write an equation to represent each total, or it's going to be like the last one from the notes, where there's 2 people, and each total is going to represent what each person bought. There's a couple other different scenarios in here, but those are pretty much kind of the two main types of word problems that we're going to be working with. So if you would like to try now working on some of the other homework problems, that is kind of your goal next. All right, so good luck, guys, and you can get started on the homework for tonight.